1. Hook, ever wondered why your AWS costs keep climbing, even when you think you've optimized everything? The answer might be hiding in your NAT gateway. Stick around to uncover how this silent killer can drain your budget and how to avoid it. If not managed properly, they can lead to unexpected bills and performance issues. For startups and beginners, this can mean the difference between scaling smoothly and running into serious financial trouble. 3. The simple explanation. So, what exactly is a NAT gateway? Simply put, it acts as a bridge for your private resources to communicate with the outside world. Here's the catch: every byte of data that passes through it has a cost. AWS charges based on the amount of data processed and the uptime of the gateway. Data transfer, for example, AWS charges $0.045 per gigabyte for data processed by NAT gateways. Hourly costs: the NAT gateway itself costs about 5 cents per hour. Let's break this down. If your application sends 1 terabyte of data through the NAT gateway in a month, that's a whopping $45 just for data transfer, plus $36 for the gateway itself, totaling $81. 4. Real-world example: let's look at a startup called Cloud Innovate. They launched a new application that required several microservices communicating through a NAT gateway. Initially, they estimated their monthly data transfer at around 500 gigabytes, leading to projected costs of about $30 for the gateway and $22.50 for data transfer. However, as their user base grew, data transfer skyrocketed to 3 terabytes in a month, totaling $135 just for data transfer, alongside $36 for the gateway, which resulted in a total bill of $171. They were blindsided by these costs and had to scramble to find a solution. In hindsight, they realized they could have optimized data transfer by refactoring their application architecture. Instead of using a single NAT gateway for all microservices, they could have segmented traffic, reducing unnecessary data transfer. 5. What to do instead? Here's a practical framework to manage NAT gateway costs effectively. Step 1. Assess your needs. Evaluate your architecture. Do all resources need internet access? If not, consider using NAT instances as a cost-effective alternative. Step 2. Monitor data usage. Use AWS CloudWatch to set up alarms for data transfer thresholds. For instance, set alerts at 100 gigabytes increments. This keeps you informed before costs spiral. Step 3. Optimize your architecture. Split workloads across multiple NAT gateways if necessary. Design your application to minimize unnecessary outbound traffic. For example, cache results that don't require constant updates. Step 4. Analyze traffic patterns. Identify peak traffic times. Schedule heavy data transfers during off-peak hours. Use AWS Cost Explorer to track monthly spending trends. Step 5. Review regularly. Set up a quarterly review of your AWS architecture to ensure you're not overspending. Look for better pricing models, like reserved instances, if you foresee long-term usage. 6. Common mistakes. Mistake 1. Not monitoring costs regularly. Fix. Set up AWS budgets to alert you when you approach your spending limits. Mistake 2. Using a single NAT gateway for all traffic. Fix. Implement multiple gateways for different workloads, especially for high-volume services. Mistake 3. Ignoring data transfer charges. Fix. Use VPC flow logs to analyze traffic and understand where your data is going. Mistake 4. Failing to optimize outbound traffic. Fix. Minimize unnecessary API calls and leverage caching strategies. Mistake 5. Not using cost-effective alternatives. Fix. Evaluate using NAT instances for predictable traffic patterns. They can be significantly cheaper with proper configuration. 7. Quick checklist. Assess your architecture for unnecessary internet access. Set up CloudWatch alarms for data transfer limits. Split workloads across multiple NAT gateways if needed. Analyze and optimize traffic patterns regularly. Review architecture quarterly for cost-saving opportunities. 8. Summary plus CTA and summary. While NAT gateways are crucial for internet access, they can also become a silent killer of your AWS budget if not managed properly. By assessing your needs, monitoring data usage, optimizing your architecture, analyzing traffic patterns, and reviewing regularly, You can keep costs under control. If you found this information helpful, drop a comment below with your experiences or questions. Don't forget to subscribe for more practical insights on AWS and cloud engineering. Bonus practical tip: if you're unsure what to pick, start with the simplest option that ships today. Then measure for 7 days, latency, errors, deploy time, and cost. Only upgrade when metrics force the decision, not fear.